tossing of a coin. So I take, say, n tosses, n equal, say, 100, and I generate random numbers and I will count heads, right? So I say n heads equals 0. So I say for jj in range n, and I define x equal to numpy random dot random number, which means one toss, right? So a toss comes out with one value, and now we have to see whether it is head or tail, right? So from the random number generator, we have numbers, and the numbers are uniform in number. So we can say, okay, half of the range is to represent head and half is to represent tail. So now this is the toss value, numerical value. So I can say here, if x is less than or equal to 0.5, my comment is it's head. It's a head. And when we get head, what we have to do, we have to update the number of heads. So n heads equals n heads plus 1. So head has been counted here, and end of the program. Now I print the outcome, which is the number of heads. So number of heads equals, I say, n heads. And that's it. And let's see whether it can generate the similar kind of results or not, right? So let's run it and wait for the results. 45. When you perform the experiment, is it possible in 100 tries you get 45 heads? Yes, it's possible. Run it again. 49 times. Okay. So if one toss with the real coin, it is possible to get 49 heads. Another person performs the experiment, get 45 heads. Another person performs the head 46 times. So the random numbers are adequate to simulate the tossing of a coin process, right? But we require further explorations, right? If you have certain concerns, they are logical. But after my next demonstration, you will be amazed with the power of Monte Carlo. So here I'm going to write a program to compute the probability of getting 3 heads in 5 trials. So I first initialize the number of experiments in Monte Carlo, say 40 experiments, right? And in every experiment, there should be 5 tosses of coin. And I have to count the 3 heads. Okay. So I say here, okay, 3 heads. 3 heads, it is equal to 0. Now the experiment begins. So I say for the 8th experiment in range n experiments. This is for all experiments. And in every experiment, I will count the heads equal to 0. So now here comes the experiment. In every experiment, we have to perform tosses. So I toss in range. I have to toss 5 times. So IH toss is going to be there. So I toss. One experiment, this is one experiment. In every experiment, 5 times we have to toss. So is equal to numpy random dot random. So if x is less than or equal to 0.5, so we know what is this? It's a head. It's a head. So I have to count the heads, update the head count. So I say heads equal to heads plus 1. Okay. One experiment completes at this point. That experiment has been completed at this point. This is one time we have tossed a coin 5 times and we counted number of heads. But our desired success is number of times we got 3 heads, right? So now the other condition, if in this experiment the heads are equal to 3, if the heads are equal to 3, now this is the desired success. So now I will update the 3 heads, count of 3 heads, right? At this point, I say the count of 3 heads equal to 3 heads plus 1. Please note it, that if the desired outcome is there, then we accept that experiment. We add the count, and that's it. If some condition is there, and the end of all experiments. Now I compute the probability of getting 3 heads. It is equal to 3 heads divided by the total number of experiments. Let me check whether the variables are correct or not. In experiments 40, 3 heads. Experiment in which we get 3 heads, 0. So the first experiment begins. The first experiment we have to toss 5 times. So I toss 5 times. So x is random number. 5 tosses will be generated. And if the head is there, head count is increased. So at this stage, we know the possible outcomes are 0, 1, 2, 3, 4, and 5. There can be 0 head, there can be 5 heads, there can be 1, 2, 3, or 4. Any number of heads can appear in one experiment. So if in this experiment we get exactly 3 heads, so we will update that experiment count. And that's it. Okay. Well, I need the print statement. Okay, let's print that one in the next cell. Probability 3 heads. So it has become 0.25. So we have tested our calculation. Now let's improve the number of experiments. I say 100. And for 100, this has to be activated. 0.32, right? And this is, to my knowledge, this is relatively closer. If I get to say 1000 and see the result, .298. Let's run it again. .305. It seems the value is about to fluctuate around 3, right? And let's see the analytical result. And analytical result, behold, it is 0.3125. I have not used any expression here. It is just like the real experiment, real life experiment So Monte Carlo works. Monte Carlo works.